Okay, so how is everyone today?
Good.
Good? All right. So this is college algebra, right? Okay, good. Just make sure I'm in the right place. This is out of focus. Okay, so I'm the instructor, Dr. Brady McCary. I'm the one that's sending you all the messages, but they're important, so you should read them, please. So just as some information about the way the course will go is that as far as like how it works in the classroom is that I'll write on these pages. Okay, so like I'll always write the date on the first page there. After lecture's over, I scan these pages and then I post them online. Also, I teach a different section of the same thing, but in the morning. But this is the one that I'm videoing. So like there's a camera running right now. And later today I'll post it to YouTube. But these things being said, don't take that as license not to come and participate for a couple reasons. Okay, so the first reason is that we're gonna have homeworks and quizzes every lecture. Okay, with stuff occurring at the beginning, at the end. So you might as well be here in the middle too, right? Second is that try not to treat this as like a TV show. I'll try to be entertaining because after all it's a math class, okay? And otherwise it'd be too boring to sit through. But don't treat it like a TV show because the more engaged you are, the more likely it is that you're going to understand and retain. Okay? So any question about just those superficial matters? Okay. So information about me. The best way to contact me is by email. So my email address is this. Everybody, all of us, have a UTD email address, and the UTD policy is that because you're taking a course in which I'm the instructor, that means that now we have an official university relationship, which means that it is only permissible for me to email to your UTD email address from my UTD email address and vice versa. And that basically means that I understand entirely that you've probably got a Gmail account, because everyone does, right? But if you send me an email from your Gmail account, I'm just going to delete it. Okay? In fact, it'll automatically be deleted. And if you speculate concerning my UT Dallas email address, you might speculate what my Gmail address is. Okay, but if you send me an email there, I'll just delete it. Okay, it basically comes down to this. Just like your doctor would be in a lot of trouble if they just said, here's this person's medical records. Do you want to just have them? You can't do that. Okay, because there's laws against that. In the exact same kind of way, your academic educational instructors have exactly the same law. So like, I have no idea who you are if you're talking to me over Gmail. Okay, so just delete. Good. My office is FA 2.402. Since this is a fall semester, many of you may be brand new, and one of the fun things about campus is that there's 3 buildings with Founders in their name. One of them is Founders, the other one is Founders North, and the other one is Founders Annex. And to make it more fun is that all of them have a 2.402, and all of those 2.402s have math people in it. But so if you go to like Founders 2.402, there'll be math folks there, but not me, because I'm in Founders Annex. Okay, good. Is there anything else about that? Not really. I sent you a bunch of messages, like to your email, Okay, please read those carefully. Concerning just the way the course goes, like assignments, how your grade is calculated in the end, is that there's basically two kind of categories of assignments. There's online homework. We're going to call these OHW. We're going to do those on WebAssign. So if you've never done, never had that lovely experience, it's basically just a website that you log on to, and you're given math exercises, and then you type them in. Okay, so that's the one thing besides tuition. That's the one thing for this course that you need to purchase. It costs on the order of like $35 or something like that. So you're going to have to pay for that. I sent a message about it. Please read it. This is the textbook. The textbook has the nice property that it's a free textbook, so you can just download it. You know? I mean, you can't download a physical copy, so if you're the kind of person who likes physical books, then well, you still got to buy it, but it's pretty cheap. So that's nice. I don't care if you get a textbook or not. Any questions so far? So there's that. Then we have written exercises. And we're going to call these WEX for written exercise. There's two varieties of WEX. There's a homework WEX. And there's quiz WEX. Okay, so the homework ones are on that box thing that you get all the messages about. On box there'll be some PDFs. You download them, print them, do the math exercises on them, bring them to class, and then there'll be boxes all lined up where you put them in the boxes. Okay, so that's the homework kind of written exercises. Then during lecture, we'll have quizzes where you come in and you do a quiz. Okay, there's no further explanation really is needed about that. It'll just be one exercise, but we're going to have one for every lecture. Okay, so now the main mechanism of the course, the way it works, is that our meeting pattern is Monday, Wednesday, Friday. So like today, yeah, I'm sorry, I don't know what to say. It's Monday, Wednesday, Friday, and this is the very first lecture. So then this lecture is referred to, the one we're in even now, as lecture 0. Because all good mathematicians start counting at 0. So this is lecture 0. The next one will be lecture 1, and then lecture 2. Okay? So then next week, there's going to be another Monday, Wednesday, Friday. All right. So now, from this lecture, we're going to eventually, after discussing these just logistical details, we're going to get to some math. There'll be an online homework posted. In fact, it's already posted. It is due 1 minute before Monday. So it's due Sunday at 11:59 p.m. Okay, and then this will be lecture 1. This particular online homework is named OHW 00. Now it's called 00 because it's in correspondence to lecture 00. Okay, so this one is lecture 01, so it'll have an online homework, and it'll be due 1 minute before Wednesday at 11:59 p.m. Its name is OHW 01 because it's in correspondence to lecture 1, etc. Oops. Okay, so that's the online homework. Good. So as for the written homework, so this is Monday. This is right now. Okay, and this Monday is 7 days less 8 minutes from now. Corresponding to this, there'll be several written exercises. So the first 4 written exercises are just instructions. Okay. So their names are WEX, and then 00 because that's corresponding to lecture 0. And then to just to make the name of the exercise unique, another 0. So WEX 000. And then there's another one, WEX 001, because that's the next one. And then WEX 002, etc. Okay, so it keeps going down the line. Now, like I said, the first 4 are just instructions. You just got to download them, print them, sign them, and bring them. There will be a couple more that are actual math exercises, and you got to bring those too. Okay, be sure to read the instructions carefully. Now, on this Monday, in that lecture, besides turning in those homeworks, let's say that it ends up counting all the way to, say, like here, WEX 00, and then say like 6. But those are all the homeworks. Okay, then besides those, there'll be one more. .007, and that's a quiz. That's something that you come in and it's just a quiz. One exercise. Any questions so far? So all of these are in correspondence to lecture 0, and you can see that because the first 2 digits are 0. Okay, then corresponding with these would be the first 2 digits would be 01, for these 02, etc. Okay, this also means that there's nothing due this week. Okay, now of these WEXs is drawn the vast majority, 80% of all of your course grade. Okay, so let me explain. So besides the instructions, okay, we can rule those out. Generally, there will be less due because there's not going to be 4 instruction WEXs every lecture. So generally, there's going to be like 4 or 5. All but one of them will be homework, and then the last one will be a quiz. And then of these, 2 of them are selected to be graded out of 10. Okay. So suppose that this one is selected to be graded out of 10. That one right there. Usually I select the quiz because it's one of the few that I can be sure that you did it, right? Instead of like your buddy. So if that's the case, if this is graded out of 10, okay, I don't announce ahead of time which ones are going to be graded out of 10. Because if I did, then you might choose not to do the other ones. If that one's chosen to be graded out of 10, what that means is that there's now a grade in the course that would be called WEX A, and then 007. Okay, and your first attempt at it would be on that quiz. The name of that grade will be WEX 007, so that's the name of the assignment. And then the one and only question on that assignment would be, its name is 01. Now, I would love to name the first question 00, but there's a silly technical reason why I can't do that, so I just have to bear its name being 01. Okay, so that's going to happen in a week. Okay, maybe it, and all out of 10 questions, of course, are out of 10. So maybe it comes to pass that, you know, you're not really so excellent at the task that the quiz is over, and maybe you make a 3. Okay, well, that's concerning to me. I'd rather all of you make, you know, 9s and 10s, like on everything, but it won't happen. Maybe you make a 3. All right. Well, later on the midterm, the name of the midterm is called mid. And because 007 was graded out of 10, that means that there's going to be a question on the midterm whose name is 007. Now, at your option, you can redo. You could submit a redo for 007. Now, it won't be an identical question, but it'll be a related question. Okay, related enough that I feel just fine saying yes, these two, whatever they scored on them can be substituted one for the other. Okay, so maybe here you make like a, you know, like a 6. Okay, that's out of 10. You know, so that's it's not awesome, but it's better, right? It's better. Okay, so that would mean that now your grade for this one is 6 out of 10. It was 3 out of 10. Now it's 6 out of 10. Okay, then perhaps on the final, whose name is Finn, again there will be another question named 007, and at your option, you can choose to redo it or not. Let's suppose that you make like you know, like an 8. Okay, so then now I have 3 measurements for you for the same topic, the same skill. The way that this grade is made is it's just whatever is last. So the last thing you submitted, it was an 8 out of 10, so your grade on that one is 8 out of 10. Okay, but do understand that because it's whatever you did last, it is in fact entirely conceivable that your grade could go down. Okay, so like, you know, 3, 6, 8. Okay, good. 3, 6, 4 is less happy because then you'd have a 4. So now the vast majority of your grade in the course is there's going to be like on the order of like 40 to 50 of these out of 10 questions, and those are going to constitute essentially 80% of your grade. You have you know, the ones that occur early in the semester, you're going to have 3 attempts. The ones that occur relatively late, you're just going to have 2 attempts. Okay, the first time and the redo on the final. Any questions so far? This is all fine? Okay. So, very good. No questions? Amazing. I'll leave it open for just a second. Okay, so now this sounds really good, and it is. So let me make it sound even better. Before I tell you the bad news, this sounds really good because it is. Okay, one of the things is that you know, in other math courses, because we're you know, this constitutes 4 different measurements, 3 measurements, and then I calculate something. So that means that in the grade book, you know, you're going to have like 500 grades. You know, you know, because they're all going to be in there by the end of the semester. So that's nice. In other math classes, what they in fact do is that you know, you in fact get asked the same question over and over again. Not exactly the same question, but conceptually the same. And effectively in those math classes, what this means is that 3 plus 6 is 9 plus 8 is 17. So out of 30 possible points, you made 17. And so in such classes, you have a 17 out of 30. That's what that means. But in our class, this sequence of events would mean that you have 8 out of 10. And 8 out of 10 is better than 17 out of 30. Okay? So that's good. That's really good. But that you know, you might wonder, oh man, how does anyone pass one of those other math classes? If that's the case. Well, in the end, the reason is because the instructors just inflate your grade until enough folks are passing. But we're not going to do that. Rather, what we're going to do is I'm going to grade every one of your questions as if it's a final exam. And if it's not right, it's just not right. But I'll clearly explain what's not right about it, and moreover, I'll post keys to all of the assignments, including PDFs and videos, and you can see exactly what I think constitutes an exactly right answer. Okay, so then it's good, because this means 8 out of 10 instead of 17 out of 30. But it's also bad, because I will be holding you to the standard of the final exam all semester long. Now, to be clear, if next week you make a 9 out of 10 on this one, more or less what that means is you never have to do this question again in this class. Any questions? Okay, let's get to the material. All right. What was I? Oh, yeah. Sets of numbers. Fine. So then, in the first place, we have the naturals. So there's a set of numbers that are called the naturals. They're denoted with an N. Now it's a bold N, but I don't have a bold pencil. So this, that's an N, but its left leg is like a box. Okay, that's a stylistic convention that means that I wrote that in bold. But I don't have a bold pencil. It's just a stylistic convention. The natural numbers is the set containing 0, 1, 2, 3, and onward. That is to say, the non-negative integers. Can someone give us an example of a number that's not natural? Sorry? 2.5. 2.5. Okay. 2.5 is not natural because it's not an integer. Okay. How about -3? Is -3 natural? Not according to this definition of natural. This is not like a moralistic thing. It's just not in this set, -3. Okay. Then the next bigger set that we need to know by name is called the integers. Integers. It is the set which contains, well, all of the naturals and furthermore all of the negative integers. So 0 and then also positive and -1, positive and -2, positive and -3. Good. So observe that every natural is an integer. So like for example 5 is natural and 5 is an integer. Can anyone tell us an integer that's not natural? -2. Okay, thank you. Now, if the naturals are denoted with n, then what are the integers denoted with? No, with a z, obviously. Sorry, I set you up there. Z because when this convention was being set down, it was being set down in a German-speaking country, and in German, the word Zahlen, which starts with Z, means number. Okay. Well, history's history. The next bigger set that we need to know is called the rationals. This is the set of all numbers that can be represented as one integer divided by another integer. Now, the way that you write that in math notation is like this. The set of all p over q such that p and q are in the integers. The state of Texas assures me that you're completely familiar with what I'm writing on this line, but they've been known to make mistakes from time to time. So just to remind you of these things that you know, you pronounce this out loud as the set of all p over q such that p and q, oops, I left something off, are integers, I left off something important. Integers. Let's see if we can figure out what I left off. Okay, so can someone give us an example of a rational? 3/5. That's a rational because, well, 3 is an integer, 5 is an integer, and that's the ratio of two integers. So it's a rational. How about something like say like 8? Is 8 rational? Yeah. Why? Yeah, because you could write it as 8 over 1. Is that the only way to write 8 as a rational? 16 over 2, right. So there's lots of ways, infinitely many ways, right? So, yep, that one is. What about 0? Is 0 rational? Okay, I've heard. How can you write it as a rational? 0 what?
No, 0 is not rational.
What if you go to a party and there's a pizza, it's cut into 8 pieces, and you get 0 of them? Then how much did you get? 0 out of 8 of the pieces? Yeah, it's rational, right? But here's a number. Here's a ratio of two integers, or anyway, it's two integers that I write them one over the other. How about this? Is that a rational?
No.
It is not. So what did I leave off in the definition?
So q is not equal to 0.
Yeah. So I left off up here. It's the set of all p over q such that p and q are in the integers, and q is not 0. Okay. Good. So 8 over 0 is not a rational because it's not even a number. It's not even a thing. But can someone tell us a number that is a number, a thing that is a number, but it's not rational? Tricky. Did someone say one? Infinity is not a number. Okay, here's a good one. How about pi? Pi is a number. That is to say the circle constant, pi. Pi is a number, but it's not rational. That means that you can't write pi as the ratio of two integers. Now I know it might be the case in some of your math classes that your instructor might have said that 22 over 7 is kind of close to pi. And okay, no dispute, but it's not equal to pi. Okay, pi can't be written as the ratio of two integers. Okay, neither can the square root of any prime number. So for example, the square root of 3 or the square root of 2 can't be written as the ratio of two integers. So the rationals have lots of gaps. By the way the rationals are written is with a Q for quotient. But the rationals have lots of gaps. Like pi, the square root of 3, and other stuff. Okay. Well, we want a set of numbers. We want a set of numbers that has all the rationals in it, but doesn't have any gaps, like nothing's left out. So the name for that set is called the reals. They're denoted with boldface R. And this is in this class there's no very precise way to say it, so I'll just say all the numbers. All the numbers on the number line. And there are no gaps. Okay. So in particular, pi and the square root of 3 and all that kind of stuff, they're all real. So even the name real is a joke. And by the end of next week, I think you'll understand the joke. I hope. It might be, we might make it to the third week. I don't know, but it's coming. But do know that every time I say real numbers, I laugh a little bit inside, and I hope that you too will laugh. Any questions so far? Okay, so now let's talk about the order of operations. All right, so we'll do this with an anecdote. So here's a fun thing, is for me anyway, is that in my family I'm like the only math person, right? Everybody else is doing other things. But so as a result, every time I go to something like like Thanksgiving or whatever, I get asked just inane questions. They're just trying to aggravate me. They'll say something like, what's 4,778.9 multiplied by, and like they'll just rattle off some other number. Like why would I know that? I don't know that. But they ask that to aggravate me. Another example where this comes up is that have you ever seen one of those things on Facebook or Twitter or whatever, where it's like they put some math thingy on there, and then they say, everybody post what you think the answer is. And there's like 80 different answers. Everybody's getting the different answers, and no one can agree on what's right. Okay, so we're going to talk about this because here's the deal: is that I know you learned the order of operations before you got here, but it's extremely likely, verging on certain, that you were lied to. So like your fourth grade teacher, Mrs. Harris, as nice as she was and sweet and everything, and how much you loved her and cared for her, she lied to you about the order of operations. Okay, so everybody knows that there's this word, this initialism, that is pronounced as a word for the order of operations. What is it? PEMDAS. That's wrong. Can you believe it? It is not PEMDAS. It's not PEMDAS. That perilous Mrs. Harris from fourth grade or whenever that was. Okay, the real order of operations is actually P and then E. So far looking good. But then these two are on the same level. M and D have the same level. And then A and S, they also have the same level. And what happens is that when you have two things that are on the same level, you have to break ties. Okay, and the way that ties are broken is that on both of these levels, ties are broken left to right. Okay, so let me explain what I mean by that. So here's an example. I could say, okay, how about 60 divide by 4, multiply by 3, add 7. Okay, so we've got three different operations in this request, and 4 operands. So operations are the punctuation, and in the things that aren't punctuation, those are called the operands. So like just concerning say just that, the operation is multiply, the left operand is 4, and the right operand is 3. So let's label all of the operations according to the PEMDAS scheme. So what's the name of this one? That's a D, right? And what's this one? That's an M. And this one? An A. Okay. Now if PEMDAS were the truth, then that would mean that we'd need to do that multiplication, right? Because the M comes before the D in PEMDAS. So let's proceed as if PEMDAS is true. If PEMDAS were true, that would mean that we take, I'm just copying that down so that we can have something nice to look at. That would mean that of all of these choices, the D, the M, and the A, we would select the M. So that the next answer would, the next line of calculation would be 60, divide, and then 4 multiply 3 is 12, and then add 7. So now we can relabel the operations. This is a D and this is an A. So between D and A, who wins? The D wins because it's you know, in PEMDAS the D is before the A. 60 divided by 12 is 5. Now we relabel the operations. Of the available operations, which one are we supposed to choose? The A, right? The only one. And then 5 plus 7 is 12. Okay. This would be the case if PEMDAS were true. So now, but it's not. So now let's write the correct way. So here's the deal: is that we have 3 choices, D, M, and A. So of those choices, which choices have the highest precedence? D and M. D and M have the same level of precedence. They're on the same level. So D and M are on the same level. Therefore, we must break a tie. And how is the tie broken? Left to right, which means that of all the things that you've chosen, okay, the correct one is to choose the leftmost one. Okay, so therefore, we choose leftmost, and the winner is therefore which one? D. So this would be 60 divide 4, multiply 3, add 7. Again, this is a D, M, A. D and M are tied. We choose the leftmost one. 60 divide 4 is 15. 15 multiply 3, add 7. Now we have a M and an A. Between M and A, who wins? M wins. So this would be 45. Then add 7. This is an A. There's only one operation, so that must be the one. So the answer is 52. Now, are those two answers the same? They're not the same. So now here's the deal: is that y'all just met me, right? You don't know if I'm misleading you about arithmetic. I mean, after all, Mrs. Harris was pretty great. So here's the calculator. And I've typed in that thing. And maybe we'll let Texas Instruments be the arbiter of truth. So what's it going to say? 52. Mrs. Harris. Miss Harris. Why have you done this to me? So you can go back and look at those threads on Facebook and things like that. And you can, if you didn't understand what the deal was, now you do. Because the majority of those, in my experience, are basically come down to the order of operations. Any questions about it? Okay. Good. No questions before we move to the next thing? Okay. So, here's another matter. Another interesting kind of thing that we can work on. So this is express a repeating decimal as rational. Okay. So now, just as a minor example, this is not the one we're going to work on. But, you know, for example, 0.3, and then I put a bar over it. What is the meaning of that bar? Yeah, it's repeating, right? So that means, you know, you could write it like this. You could say that's a 0.3, and then another 3, and put a 3 over that bar, if you like. Sorry, a bar over that 3. You know, but generally speaking, it means that 0 point, and then the 3's go on forever. Okay, but this is one that everybody knows. How do you represent 0 point infinitely many 3's as a rational? 1/3. Okay. Okay, but this isn't the question. I just want to make sure you understand what the question's about. So here's an example. I could say express 13.14 repeating as a rational. Okay, so now, as a reminder, what you're learning in this class is how to make a clear and compelling argument. Okay, so then to some extent on some of these problems, you can some students can just look at it and just kind of just say, oh, I can see that it's got to be whatever. You're just going to get a 0 for a response if you just write down the answer. Okay, because what we want to see is we want to see you working through the process. Okay, so then specifically we want you to show your work. It's your work that's being graded. If you're not showing your work, then there's nothing to grade, and you'll get a 0. But that's okay. You know, you don't really believe or understand that you've got to show your work. That's one of the reasons why we do the redo thing, because many students can't really believe the standard that they're being held to until they get a nice round 0 on the first time that they take an exercise. So please, I hope you're listening carefully. So what I'm going to do is I'm going to show you how to, what I consider to be a completely correct 10 out of 10 response to this question. Okay? Your work is what's being graded. All right. So express this as a rational. So notably, notice that 13.14, by the way, the 1314 thing is a joke, right? It's a joke. It's going to be a recurring joke in the class because the course number is 1314, right? Okay. So the first question is concerning this number. How many digits are repeating? 2 of them, right? In principle, I think you could understand that I could write down like 12 digits and then put a bar over it, and then there'd be 12 of them repeating. Okay, I'm not going to do that because that'd be painful, but understand it could be that way. So notice that there are 2 digits repeating. Now, what base do we count in? Not a trick question. Base what? Base 10. Well, why do we count in base 10? Is there's like something magical about 10, like mathematically? Because there's something special about pi, the number, the circle constant. Is there something special about 10? No. Then why 10? I'll give you a hint. Essentially everyone in the world counts in base 10. But some people count in base 20. 10 fingers. It's as simple as that. That's why we count in base 10. A complete historical accident. If it had come to pass that we had 8 fingers, I guarantee we'd count in base 8 or 16. Right? Fingers and toes. So computers count in base 2. Now the thing about counting in base 10 means that it's particularly easy to multiply or divide by 10 in base 10. In base 2, it's particularly easy to multiply or divide by 2. When we're counting in base 10, what is the effect of multiplying by 10? Yeah, in particular, it shifts the point, and it may put a 0 on the right. And similarly, dividing by 10 is you shift the point to the left. So, because there are 2 digits repeating, what we're going to do is that we're going to multiply by 10 to exponent 2. If there had been 8 digits repeating, we'd multiply by 10 to exponent to 8, to exponent 8. So now, what I'm saying is that we'll say let x be that number there. Okay, now we're going to multiply by 10 squared, which is 100, right? Then 100 multiplied by x. Well, what does that do? Well, it shifts the point to the right 2 positions, right? So that would be, well, in the first place, let me write it like this. I'll say that would be 100, and then we want to multiply this by 13.1414, like that. So I put, you know, I made the 1,4 repeat over there, and now I'll move the point so that this looks like this. That'd be what? 1314.14. Repeating. Any question about that? So you never run out of those 1,4s. There's infinitely many of them. All that we did is we shifted 2 of them to the left. So now, here comes the trick. So if you take those 100 x's and you subtract 1 x, let's watch what happens. On the one hand, we know that 100x is that much, right? 100x is that much. So that'd be 13, 14 point repeating 14, and then subtract. And how much is x? Yeah, 13 point repeating 14. Now let's look. Look at that fractional part. Right? Look at the part for each one of them that comes after the zero, comes after the point, I mean. Well, let's have a look. We can express that first number as 13, 14, and then plus 0.14 repeating. And then we can express that second number as just 13 plus 0.14 repeating, right? So what happens to that repeating part? They just cancel, right? They're gone. You know, this one had infinitely many of those repeating 14s, but so did this one. And then you subtract them, and then they're all gone. So after you do this, what do you have? 1301, right? Because it's 1314 minus 13. So you have 1301. Well, how much, if this is 100 x's and then you take one away, how many x's do you have? 100 x's minus one of them, 99 x's, right? So now we have a nice equation. Can you solve for x? So x is 1301 divided by 99. Okay, now let's make sure that this is right, okay? Because after all, it's a little bit complicated of an argument, especially if it's the first time that you've done one like it. So, you know, unless I've just been blowing smoke for the last 10 minutes, when I press enter, we should get that number right there. Oh, it worked. Terrific. So now, once you've done enough of these, you can probably just answer the question, like without showing any work. And like I said, if you take that course, you will get a 0, because it's the work that's being graded. All right. So have a nice Monday, and welcome all new students to the university.